Hey everybody, let's talk about absolute value functions. An absolute value function is a type of piecewise function, but the uniqueness of an absolute value function is that it has linear parts. So piecewise functions can have curves in them, they can have quadratics, they can have cube roots, anything like that. But an absolute value function is just going to be made up of lines. So the parent function for an absolute value equation is this right here. It's y equals the absolute value of x. And you guys have probably seen the absolute value symbols before. They're basically just like two straight lines on the outside. So it is a V-shaped graph, so that's going to be important as we go through this. So every absolute value function is going to be the same shape. It's just going to change locations for the most part. So if we look at this first example here, it says graph the equation f of x equals the absolute value of 2x minus 4. Now before we get started, just remember f of x is another name for y, and remember when we are talking about absolute value functions or absolute value in general, if I tell you the absolute value of negative 2, remember absolute values make any number here inside positive. So I could say the absolute value of negative 102 and your answer would just be positive 102. And the absolute value of 4 is just 4. So that's going to be very helpful when you're plugging in numbers in order to get your points. So all you're going to do for these is just plug in some x's and get the y's out. So I'm going to plug in the x values here and I'm going to get my y values out. So let's start with something really simple. Let's say we plug in 0. If I plug in 0 to this, 2 times 0 is 0. The absolute value of 0 is 0 again. And 0 minus 4 is negative 4. So there's my first ordered pair. So I can go ahead and plot that right there. Then maybe I plug in positive 1. So I'd get 2 times 1 is 2. So I have the absolute value of 2 minus 4. Absolute value of 2 is 2. 2 minus 4 gets you negative 2. So now I can go to the point 1, negative 2. Okay, and then I can do the same thing with positive and negative numbers. So I'm going to go ahead and plug in negative 1 into this equation. 2 times negative 1 is negative 2. So when I have the absolute value of negative 2 minus 4, that's going to simplify to 2 minus 4, which also gets me negative 2. So what you should notice as we start plotting points here is that this graph is going to be symmetrical, which is very useful because if you can find the center point, then all you have to do is get a couple points on each side and just mirror them. So maybe I plug in 2 this time. 2 times 2 is 4. I get 4 minus 4, which is 0. So at 2, a 0 here, which means my other side is going to be over, so I'm going to go up 2 and over 1 there. So notice I went up 2 over 1, up 2 over 1. So if you can find the pattern between your points, you're good to go. And then like we said earlier, all absolute value functions are V-shaped, so I just start at the middle point and I go up. They do go on forever, so keep that in mind. So they're going to have arrows at the end like this one does. Okay. And then if we want to talk about the domain, remember, domain is the x's. So in this case, what x values could I plug into this equation? Well, if I keep going to the left, my graph keeps going up. And if I keep going to the right, my graph keeps going up. So what this means is that my domain is all real numbers. So you can write it this way, all real numbers. You can write it as this symbol. It's like an R with an extra line in it. That means all real numbers. Or if you're going to write it in the notation, interval notation, it would be from negative infinity to positive infinity, because that means I can pick any numbers in between. All right. The range, on the other hand, is a little different because the range is going to deal with the y values. So when I look at this graph, what's the lowest this graph goes? Well, if I follow it down, 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 here's my low point. Well, what's that low point at? That's at negative 4. So my lowest value that I can hit is negative 4, inclusive. That means the bracket here says it does hit at negative 4. And then what's the highest it goes up? Well, if you notice my arrows, they keep going up and up and up. So this is going to go all the way to positive infinity. So then I can put my bracket there. And remember, the reason we have this parenthesis here rather than a bracket is because you can never actually hit infinity, so we just say that this cannot hit it. The bracket means it does hit. Okay? Or you could write this as an inequality, that the y value is going to be less than infinity but greater than or equal to negative 4. So either way you write this is acceptable. The interval notation with the brackets is what you would see if you're going to move on to pre-calc or any textbook. The inequality is kind of the more simplified version of writing it. So whatever works for you is perfectly fine by me. If you have any questions on graphing absolute value functions, just make sure you ask me in class. The only other thing I want to cover today in this section is about writing absolute value functions. Now there's multiple types of problems that you could see in terms of writing absolute value functions, but one that's pretty common to see is when we are talking about a car's speedometer. So here's an example. It says a car's speedometer reads 30 miles per hour. It says write an absolute value function for the difference between the car's actual speed and the reading on the speedometer. So in this case, there's a couple keywords that are going to help us set up this function. So the first thing is that we want an absolute value function. So you know somewhere in your equation you're going to have the absolute value symbols. Okay, then they also say here the word difference. Remember, in math, the word difference means subtract. So we're going to have some subtraction in there. And then we have two different things that we're comparing. We're comparing the actual speed versus the speed on the speedometer. So we're going to use those two things together and we're going to be comparing them. So always when we're writing an equation we want to start with the y. So we're going to write y equals, or f of x equals, and then we're going to write our absolute value. So what is the thing that we are comparing? Well, the thing we're subtracting, that we're finding the difference of, is the actual speed of the car versus the speed that the speedometer states. So we don't know the actual speed necessarily. We're just going to call that x. Okay, so x is the speed, but we're subtracting the 30 that it says on there. So what this is saying is that I could find the actual speed. Maybe they were able to measure it using some machine and they were able to tell the speed of the car, and then I could subtract 30, and that's going to be the actual difference between the speed and the speedometer's reading. Okay, so because maybe the speedometer is broken or it's inaccurate. All right, so for example, I could measure that the car's speed was actually going 80 miles an hour. Well, what's the difference between its actual speed and the speedometer? Well, 80 minus 30 is 50, and the absolute value of 50 is 50. So the difference between the two speeds is 50 miles per hour. All right, so it's a very simple equation. You just have to know that the actual speed comes first, and then your difference means subtraction, and you're subtracting what the reading is. So then you have to think about this problem. It says, what domain would make sense for this? Well, remember, domain are your x's. So what x values would be realistic for this type of problem? Well, the key here is that we don't really care what the x values are as long as they're positive, because when we're driving a car, we can't go negative speed. So in this, you'd want to have that your domain are all the x's that are greater than or equal to 0. And it can be equal to 0 because you could be completely stopped. That's a potential speed. So anything larger or equal to 0 would work for this, and that would be a potential realistic goal. All right, so if you have any questions about writing equations, let me know, but that's it for this section. Thanks.